Collective Insights is a voyage through topics and technologies revolutionizing human well-being. Groundbreaking approaches for a better world and a better life await you. Welcome to Collective Insights.
Welcome to the podcast for Neurohacker Collective. My name is Daniel Schmachtenberger. I work with Neurohacker in research and development. We are delighted to have Dr. Andrew Hill with us today. Andrew Hill is a neuroscientist, cognitive neuroscientist from UCLA, and really an expert in the field of neurofeedback, amongst many other things in terms of biosignal processing and cognitive performance optimization, and gerontology. And we'll see where we get, but we're really kind of going to focus on understanding neurofeedback, which is a method for letting the brain actually get signal about its own function and optimize itself, which is super interesting. And we're going to kind of start at the beginning, both because this is a topic we haven't talked about for our listeners before, and because it's actually a topic that I want to make sure I understand the foundations of well, because it's a topic of high interest, but not high familiarity for me. So Andrew, thank you for joining us.
Oh, thanks for having me, Daniel. Really appreciate it.
And Andrew's the CEO, founder of Peak Brain Institute, which is a place that's really kind of advancing, synthesizing the science of neurofeedback and associated neuroscientific disciplines, and then also bringing best-in-class neurofeedback for a variety of topics to the public. So we'll get to talk more about ways that people can learn further beyond this podcast. So let's start with neurofeedback is a form of biofeedback.
It is, yeah. All neurofeedback is biofeedback, although not all biofeedback is neurofeedback.
So you want to just kind of define briefly what is biofeedback?
So biofeedback at its basic level is, feedback, or in general. Let's even just drop the bio for a second. Feedback within living systems, or within all systems, are control mechanisms, and they're ways of tuning and adjusting and stabilizing and providing different sort of stability resting points for complex systems to live in and to sort of balance in these stable basins. And when it comes to EEG and other physiological signals, you're doing biofeedback when you're measuring something that is not normally perceptible. I mean, biofeedback in a psychological, cognitive, psychology sense is taking a signal that's not normally perceptible, be it your heartbeat, your galvanic skin response, your hand temperature, your tension, muscle tension somewhere. And if you measure these signals in real time, you provide a control mechanism, essentially, that really maps to how the body and brain learn in general. So, not to be specific, this is not some magical property of the brain, this feedback learning. And it's not even a magical property of living systems, because all systems that have stability tend to learn in this way. They tend to have feedback mechanisms that provide a certain shape and character and quality to that complex system. And for us, adapting to the environment is so huge that we continue to couple our brains, if you will, to the environment and learn from it, almost as an extension of our own brain. So in doing biofeedback, if we simply provide the signal of here's the information back to the brain, it can usually go, oh, that's interesting, that's me, and sort of couple to that information. When doing audio-based EEG biofeedback, we found that the coupling signal kicks in within 10 or 15 minutes. And you can find it in the EEG. And I assume something similar is happening in things like heart rate variability and galvanic skin response, but I'm not quite as familiar with the nuances of those signals as I am of EEG, so I'm not sure where it is. But essentially, by providing the signal to the person in biofeedback, meaning peripheral nervous system biofeedback. That's the line I'm drawing between biofeedback and neurofeedback, is which nervous system are you working on? And if you're working on the brain, I'm calling it neurofeedback, or the central nervous system. And if you're working on the body, I'm calling it peripheral. And the line between them, for anyone unclear, is that anything that central nervous system is encased in bone. And if it's outside of bone, it's peripheral, broadly speaking. So when you're measuring these peripheral mechanisms that are regulatory, and you provide a signal that's changing back to the brain, it goes, oh, interesting. And then you do something which is, is different a little bit in biofeedback and neurofeedback. It's a form of associative learning. And in biofeedback, the associative learning is learning to perceive the feeling of the signal, the subtle, nuanced sort of sensation of taking control of the parameter. And it's very sort of, hard to describe until you've done a little bit of it, but you practice a rhythmic almost responding to the equipment, mirroring back to yourself something going on. And after a bit, you kind of get a sense of control. And that's called skill transfer, essentially. You're sort of initiating a regularization of the feedback loop, of your sense of it, And if you practice that enough with peripheral biofeedback mechanisms, you get some control over HRV, GSR, hand warming, and a whole other host of features, because you've given the brain some information about the PNS that it can use to control the PNS, just like it's controlling the PNS with 1,000 other signals. It's extract the information from that signal and use it to tune the system. There's some sort of, there's a little bit of shaping, operant conditioning, or instrumental conditioning in peripheral biofeedback. But neurofeedback, or central biofeedback, central nervous system, is almost entirely operant conditioning, instrumental conditioning. There's some small ways in which there's some types that are not just that. But the vast majority of neurofeedback as it's practiced in the clinical world and the research world is a form of operant conditioning. Now, let me break that down for a second, because this is true in peripheral biofeedback a little bit. You're basically setting a threshold and saying, hey, system, go that direction. And so whenever you exceed a threshold or cross a threshold, the system gets applause in some way. Audio or visual feedback is pretty classic. The trick about peripheral biofeedback when you're giving a shaping operant conditioning reward is you kind of know what's happening as you cross that reward. You have a sense of it, and that's the transfer. As you learn to sense that moment of achieving some change in threshold in the parameter. The brain maps a weird sense for you, almost like adding a sense for your meat. So that you get it's like adding an extra oil gauge or rev meter to your car. It's like, ooh, more information. And if you practice it in peripheral biofeedback, if you practice it, you get control of the skill. And if you keep practicing it, you retain control over the skill, or access to that initiation of the skill. But if you don't practice it, you generally lose the skill. That's sort of one of those things. And this is sort of why voluntary, willful forms of biohacking, if you will, that are subtle, that include measuring parameters that are not usually under physiological control, that even measure parameters or, that are not measured. Things like meditation is almost a form of biofeedback. The control signal is probably more negative reward. It's still positive feedback, but it's probably aversive. I'm not doing it right kind of experience when you're meditating. That's the feedback. But generally, neurofeedback and biofeedback are positive. You apply a stimulus. Now, I mentioned operant conditioning. I do want to say one thing about that. This is not Pavlov's dog. These are Skinner's pigeons. So in Pavlov's dog and classical conditioning, you take two things that are not normally associated and you link them, you associate them. So a dog salivating with a bell ringing. Not normally something that makes dogs salivate, but if you pair it with a salivation-inducing stimulus, you eventually can transfer the learning from the steak to the bell. Skinner, on the other hand, took behavior that already existed, pecking and stepping, and shaped the direction, the amount, the quality of that behavior. So pigeons would, he really wanted to peck, let's say, 3 times on a bar. And so for a while, he'd reward a single peck on the bar, and then eventually a double peck, and then eventually a triple peck, and would shape behavior. And pigeons are actually fairly, they're able to learn fairly complex behavior, even they have fairly, tiny little brains. And they're actually rather superstitious. So if they do something one time and get an extra reward, an extra dopamine hit, they may actually put a stylized behavior into a behavior that they've learned operantly conditioned without any need for it. Basically they're like a baseball player. Oh my God, I hit a home run. Let me do this every time. And they remember those things especially well. And so superstitious pigeons is, it's kind of a problem in research. Neurofeedback, the big difference here is that you can't perceive the stimulus that is being measured. You can't perceive your theta changing, your beta amplitude changing, your average frequency of alpha changing, your coherence or connectivity between two regions fluctuating in time. And that last bit is the most important, fluctuating in time. These are not static things. These are not even one of these measures is static or independent. There's, literally billions of things happening to produce this one brain wave. You're measuring some parameter of in most forms of neurofeedback, be that the DC coupling on which it's riding, which would be things like ultra slow or slow cortical potential frequency, things like the amount of a specific band, something we call theta or beta or alpha. There's other forms of neurofeedback that might look at relationships between regions in these signal bands, or there's lots of things you can train. There's a near infinite variety of things you can get. And one of the things about neurofeedback is we don't really understand the brain. I mean, scientists in general don't understand the brain. It's still the most complex thing we come across, probably will ever come across, unless we, succeed far beyond Ray Kurzweil's dreams. And we're not really sure of the way EEG is fully produced even. As a neuroscientist, as an EEG-based cognitive neuroscience study how mind and brain are sort of intermeshed, how the brain produces the mind. They usually are sort of resource-focused. For me, it's about attention and also laterality, how things are distributed in the left-right hemisphere and how that changes, how you are, who you are, and what resources you have, which is also trainable to some extent. But the skill, the skill of cognitive neuroscience and EEG is an EEG, methodology. Science is methodology. I tell students of mine when they're thinking about grad school, don't worry about where you go, and even really all that much who you work with, as long as you're not too early and too late in their career. But beyond that, the question you should be asking yourself are, what problems do I want to work on, and what methodology do I really want to use? Do I want to learn? Do I want to get deep into? Because, PhD, as the joke goes, is an art of learning more and more about less and less until you know everything about nothing. You get there through exploration of a space, of science, of knowledge, using a specific lens and tool set. And these things are complicated and take a lot of effort. Well, EEG is an incredibly deep field, and we don't understand at its base level what's really going on. We understand at the cellular level how EEG is produced. It's firing of mini columns or micro columns in the cortex. These are sort of mini CPUs, 30,000 neurons, a group of glial cells, some vasculature, some long-term and short-term connections. This is the sort of basic functional computational unit of the cortex. We know that. And we know that all these cells tend to fire together within this group, and when they fire at a certain rate, the ones at right angles perpendicular to the scalp or the skull, their signal aggregates enough and is perceptible through the attenuation layers to get picked up. That's probably a third to a half of the electrical signals, the dipoles being generated by microcolumns that are actually pointing the right direction. At least half are probably pointing into the sulci and not on the tip of a gyri. And so you miss a lot of that. FYI, MEG measures the other axis, the other horizontal axis, but you still get only partial information. So EEG scientists are getting partial information from the scalp of a complex system of a couple billion CPUs that are actually mostly tied to each other recurrently, where if you push on one, they all change. So what's happening is we're measuring a phenomena, especially as human-focused cognitive neuroscientists do EEG, especially as neurofeedback people and attention-driven people. We assess the brain from a perspective of what is the phenomena we're seeing and what might optimize, what might this mean? This is one of the things people don't understand necessarily about things like EEG analysis of the brain. Like QEEG is one example, quantitative EEG. Typically in QEEG, which is a term that means simply measuring, but it typically means measurement in contrast or in comparison to a normative database. And that often raises a lot of eyebrows. Wait a minute, well, who are these people? These are average people? I'm not average. Or I don't want to be average. So why are you comparing me to average? That's the sort of typical knee-jerk. And sometimes people assume that the goal of training from the QEEG is to train to zero z-scores or standard deviations to become average. Not typically. There are some forms of neurofeedback where that is the goal, is training everything at once automatically, and you end up with a certain shift of z-scores. That's not the traditional way to train, even though traditionally in good science, we do use QEEGs, but we use them as tools to understand the brain. prognostic versus diagnostic tools to say, this pattern at a population level often means this. Oh, hey, you're experiencing that. This might be where it is. So we use the sense of the shape of patterns we get to get a sense of the brain we're looking at and try to figure out from the hypotheses that generates what's actually real in the data. And EEG, of course, is very noisy data too. Blinks and coughs and twitches and sleep deprivation and caffeine and illicit substances and all these things have a pretty profound effect, and age for a pretty profound effect on the EEG. So in the case of EEG, there's an intermediate step in doing biofeedback. You typically need somebody to look at the brain patterns, assess them against a normative database, and then figure out what it is you want to do. Traditional, if you will, half the field, 3/4 of the field would say, let's find the problems in the QEEG. Let's do sort of neuropsych level assessments, continuous performance tasks. Depending on their specialty, people use different assessment. But for the most part, it's the general neuropsych sort of battery that people tend to use. And a CPT is the most common. And then you figure out what you want to do. Now, segueing into different forms of neurofeedback, there's a QEEG-driven form, if you will, that is sort of, let's say, purely QEEG. That was the automagic quip I made earlier. You sort of tell the software, okay, measuring all of the brain or all of the scalp at once, we're going to calculate in real time standard deviations or z-scores from this comparison database. And when 70% of the ones that are more than a standard deviation and a half move towards zero, provide a reward. But the next moment, it could be a different 70% if you're setting that kind of sort of bucket threshold. And so in that case, you're sort of providing a fairly blunt push on the brain, and you're hoping that it organizes in the way that it needs to for the most part. It's blunt but specific. And what I mean by that is it's not controllable. You're sort of providing let me see where the weak forces are. Let's see if the system rearranges when I push on the stuff that is most obvious. And that does tend to work. QEEG-driven, meaning Z-score neurofeedback. It's often called Z-score because you're in real time training from the database. It often works very well, and it often is very powerful. I do QEEG-driven neurofeedback, but I don't do it in real time from the QEEG. What I do is develop a pretty deep analysis of your brain, hundreds of pages of norms of analyses about how unusual your brain is. And we figure out, okay, well, what makes this brain data valid and relevant for you? Are there problems here? Are there interesting, curious things you might find interesting about your interconnectedness or like your speed of processing, or what might this stuff say about how your resources are functioning? I usually do that as a cold read. It's a bit of a party trick, but it works 95% of the time, the way that I do it. And what I mean by that, not true, like, speaking to the dead, Jonathan, whatever his name was, leading questions. I don't do the leading questions, but I do sort of a blind, okay, well, here we go. I think this pattern means this. This is probably this or maybe that for you. And this is this. And, oh, that's going on. Okay. We should work on this and maybe that. And usually by the end of the first or second sentence, people are like, how did you have, because I don't do a clinical interview. I'm not a psychologist. I'm not saying, let me do a deep history. Let me figure out, your relationship with your mother. We don't ever ask you about your mother unless she wants to train. And then we ask a lot, And if she wants to come in and get a brain map and it helps us inform our idea about your brain, that's the kind of stuff we want to know about your mother, not so much anything else. We don't need to. And so in that sort of layer of neurofeedback as an industry, which is probably at least half the industry, will do sort of science-based, evidence-based assessments, look at your brain, try to figure out what's going on, and then sort of use a combination of things suggested from clinical practice, basically lore, and things suggested by science, which is one step removed from lore. It's sort of tested lore. And sometimes things purely suggested by the data. That happens sometimes too. And you blend all these things with your sense of how things change, with your sense of what people might want to do. And then I go after single or two or three spots at once and try to work on areas of connectivity, big sweeps of the brain, big regulatory markers, and push on specific things, 1 or 2 or 3 or 4 at a time. Not 97 this moment, 84 that moment, 6 this moment, 3 that moment. And so those are the two flavors, if you will, of QEEG training. One is Z-score driven, one is often multi-channel. and one is usually fewer channels and is typically a little more precise and sort of either relies on magical abilities in neurofeedback or it relies on deep neuroscience. You can do it either way. You can be the most incredibly gifted, intuitive person who's done this for 30 years and knows everything about how brains work, but doesn't know how they know that. There are a few people like that in the field, and they're getting amazing results. And they mostly do the same things the science-based people do, which is deep assessments and evidence-driven decision-making. And then there's a few technologies that are sort of elaborated in the past 10 or 15 years, a few of them in the past couple of years, that have less understanding about their mechanism and probably don't have the mechanism their proponents would expect or suggest that they have. And those include things like it's either infra-slow or ultra-low, things below 1 hertz. And the reason for my skepticism is there's something in physics, just the way electromagnetism works, where if you want to measure a frequency, you need to measure twice as long as the sample you want to measure. It's called the Nyquist theorem. So if you want to measure a theta wave, which is 4 times a second, you got to measure at least twice 250 milliseconds, or at least half a second to get the theta wave. And when you're below 0.1 hertz, and when you're at like 0.00001 hertz, to get a single iteration of change and to measure something in like an FFT, a frequency analysis, how much is this stuff changing kind of thing, you need hours, and you're doing sessions that are 20 minutes. So I have a hunch there's some mechanism that is not well understood. And even the proponents of these mechanisms typically will say things like, yeah, the physics breaks down. The lead, if you will, person who's one of the first people in this new ultra-low training regimen is also one of the greats in the field who created what everyone else is still mostly using, the sort of traditional band training that I do and many people do. And he's a physicist. And he says, "Oh yeah, you're right. It can't be training down there. But these results we're getting, these are great results, And it's not that they're chasing some weird model. They just happen to find something that works in some interesting way, and they're building more resources. I still prefer somewhat evidence-based stuff where we can keep going back to assessments and get a sense of how things are changing, which is why I work the way that I do. Then there's a few technologies that are sort of more one-size-fits-all, which don't work all that well. And there's some technologies that mix or use more microstimulation. Things like capital LENS, which is low energy neurofeedback system. A variant of that, a newer variant, it's called HPN, high performance neurofeedback, I think. And those are sort of microstimulation of a series of sites down the head on both sides for everyone, short sessions, not much electricity, about as much in a watch, an old school radioactive watch dial in terms of the amount of, it's pico or nano or some incredibly small unit of measure of energy, but it's enough to perturb the system. And it produces change, and it seems to work really well for a few conditions like traumatic brain injury. And it seems to work less well for a lot of the other things that neurofeedback works really well for, in my experience. I don't use LENS or HPN mostly because we get pretty good results going after specific things. And I also do a form of neurofeedback. The style is mostly something called SMR, sensory motor rhythm. And this is a sort of magical rhythm in the brain, 12 to 15 hertz in humans usually. And I have a hunch that it's integrated in a bunch of different ways that make it really useful to hack. One of those things is learning, sleep regulation is another, stability of the system is another. So if you train up SMR, you end up with reduced seizures. The seizure threshold gets dramatically lifted. And the research suggests that humans that do this end up having 30 to 50% reduction in seizures. Often like 5 or 10% of people get elimination of more than a year of seizures in the literature reviews. But this was a discovery in the field that sort of started the human neurofeedback field in about 50 years ago, 1967. Dr. Barry Sturman at UCLA was a learning scientist and had worked on cats to see if they could get a milk dropper, maybe chicken broth dropper, a little thing triggered whenever a brainwave went up. Now, cats make SMR in an obvious way, which I'm guessing is why Dr. Sturman chose this rhythm. If you've seen a cat lying on a windowsill watching birds, you've seen SMR. That incredibly inhibited body, but very alert mind is an SMR state, right? So ADHD is the opposite of that. You're motorically hyperactive, you're mentally hyperactive, disinhibited. And so I view SMR as inhibitory tone in the brain. Mm-hmm. And training that up, Sturman found, through doing another experiment a while, months later, makes the brain stable. So Sturman was hired by NASA to essentially figure out how dangerous rocket fuel is, because astronauts were complaining of hallucinations. And nausea and other things. And so Sturman would expose cats to rocket fuel and found that most of his cats had a really predictable dose curve. Ataxia, crying, drooling, seizure, coma, death. This is the late 60s. We don't generally kill cats anymore in research, but 50 years ago, slightly different landscape. And one group of his cats refused to have seizures. They had exposure times 2.5 times as long. It's like an hour to seizure for most cats, and like 240 minutes for the cats that had received some neurofeedback training in another experiment a while back. And the next step was someone affiliated with the lab had some uncontrolled seizure disorder, lots of seizures. And she's like, okay, well, we're going to, do some of this on me. And this story may be somewhat apocryphal, but the data's there. So this actually happened. And she, over the time, reduced all of her meds and was seizure free for many, many months after doing some training. And then Sturman ended up, getting some more research out there over the years on learning and epilepsy. Several more people did SMR research on epilepsy and seizure. Sturman had his funding pulled soon after he submitted his initial findings about seizure control with SMR, very rapidly without too much communication. So there's some suspicion in the field that there was some, ulterior motive from pharma to control alternative mechanisms, because at the time, in the late 60s, the neuroleptic class of major drugs was pretty profitable. It was before sort of Prozac era, so we didn't have the 800-pound gorilla in the pharma room then. So from there, from epilepsy, from instability, we discovered that, because EEG is a sleep realm as well. When you're cognitive neuroscience, you're one step away from a sleep scientist, because the history of EEG is sleep history, sleep studies, and sleep science. And so very quickly we discovered, EEG scientists discovered in the 60s and 70s that it also re-regulates sleep pretty profoundly. And oh, look at that. It sets impulsivity under control suddenly, profoundly, quickly. So it was now an ADHD sort of target when that became a known thing in the 70s and 80s. And it works incredibly well on things like ADHD now. It's sort of the biggest use. So neurofeedback, SMR training, style neurofeedback will eliminate, 80, 90% of ADHD in a matter of weeks in most people, usually long-term change. Done.
Okay. So you said, that was a great intro overview. You said a lot of things. I want to double click on quite a few of them there. And I want to start by making sure that the primary mechanism of what's happening regarding feedback itself across both peripheral and central nervous system feedback really makes sense to people. So to kind of explain it another way, we have sensory systems that sense the outer world, and we have sensory systems that sense our inner world. And so just like we've got the ability to extend our exterior senses, our eyes or our ears, whatever, through telescopes, microscopes, our ability to talk over the phone right now, which is a technological extension of a sensory system into the environment, our proprioceptive systems that are sensing what's going on inside of our body. Pretty much everyone feels a kind of neurofeedback when they're learning a new thing like balance, right?
Yeah.
And it's also similarly hard to describe when you're like trying to do something that feels almost impossible, like walk on a slack line, and it's impossible, and then all of a sudden it's kind of possible, and you can't quite describe exactly what it was, but your system figured out from a form of feedback falling how to regulate better.
Exactly. Yeah.
And what you're looking at is that all the biofeedback technologies kind of are what a microscope or a telescope is to your eyes, to your external senses. These are those kinds of tools to your own internal senses to actually increase internal sensing capacity so that the system can pay attention to its own states and learn and regulate faster.
Yeah. Any signal you provide to the brain that has information in it, the brain would like to extract that information and learn from it. If it discovers that information is itself or the body, it finds that information a little more compelling and learns faster, couples, yokes that information. Once you have that feedback loop, you can shape it by applauding shifts in the data.
Right. So now one of the most important things that you said is that the brain is this radically complex system. We've got these, millions of CPU-like things, and how good that analogy even is a question, but we have these millions of CPU-like things that are deeply coupled to each other. So when we're trying to do optimization, like we learned about optimization in complicated systems rather than complex systems where the causal dynamics were more obvious. and we're trying to optimize, meaning either increase or decrease some number of metrics in relationship to each other where we understand the causation better. When we try to optimize a system we don't understand that well, there's always a question mark, right? Like, are we optimizing for a model that is a subset of what's happening, and some of what we don't understand actually potentially getting damaged in the process, right? Because is that the externality, the side effect?
I mean, that can happen. If you train a neurofeedback protocol that produces the wrong effect, and you can do that, and you ignore the side effects, if you white knuckle it, oh, this is good for me, I'm doing the thing I should do, and you keep going, you will permanize the weird side effect. I mean, there was a parent that came into a place I worked years ago who had done 80 sessions of neurofeedback on her autistic son with a canned protocol and a system that she didn't know how to use especially well. And he went from high functioning autism to regressed self-stimming nonverbal under a table.
Mm-hmm.
And, he had been not that autistic and did a lot of work with him and moved him really forward. And then in like a month and a half, 2 months, 3 months, boom, back to 2-year-old status. Or you can disrupt your sleep profoundly, or you can make yourself anxious, or you can, so it's a pretty powerful tool that if you manipulate in ways that don't actually, the model doesn't meet the brain, you can do harm.
Right. It's like if you're doing posturally corrective exercise and you do the exactly wrong ones for you, then you can move a postural pattern in the wrong direction.
Yeah.
Now, my question though is, in that case, the symptoms were increasing, negative symptoms were increasing, and they were white knuckling. I'm curious about where someone is actually increasing a positive, but it is at the cost of externalizing somewhere else that they might not know, right? Because the brain does a lot of things.
Kind of stuff, or?
Well, in that possibility, right? So
yeah, I don't think neurofeedback has that risk.
Okay.
Or not to the same degree as something like TDCS or TMS or, one of those zapping technologies. There's some evidence those are zero sum because of how they work.
So I think it's worth saying more because we mostly know about medical interventions that cause side effects because they work on a fairly narrow band of things that we want to optimize without understanding the whole complex system. And so the drug side effects are common, and our electrostim things also have that, right? We might be increasing cognitive performance, but maybe decreasing some aspect of top-down neurologic control of the immune system, but we wouldn't even fucking know because it's a long-term thing.
Yeah, I mean, it seems to happen with zapping technologies, where if you push a bit of the cortex hard, you might get a boost briefly, if you will, in one resource, but you seem to get some limit as the brain shuttles over to react to that in the short term. It's such a profound change. But neurofeedback to some extent is exercise, and exercise done properly doesn't produce hypertrophy and postural problems and knee issues and a weird neck problem and, adrenal fatigue, if that even exists. Maybe it's from your shakes, from people taking too many pre-workouts or whatever. But done right, exercise optimizes the system. And it does not, you really can't do too much variable exercise. If you run all the time, the way you can do damage eventually with exercise. You can overtrain. And you can overtrain with neurofeedback. That's a valid analogy. But if you train the right way, physically, you don't get side effects. It's the elimination of side effects, of sleep issues, of stress, of, the homeodynamics, and where I know that you enjoy, improve. The regulatory range of the system becomes more flexible and able to re-regulate in the basin.
Yeah. So this is what I was hoping you'd speak to, because this is what I think is so fascinating about biofeedback and neurofeedback specifically, is that you're actually helping the system increase its own regulatory capacity. You're not giving it a stimulation to try and say, oh, it's too high, we're going to exogenously lower it, or something is too low, we're going to exogenously raise it. You're giving it feedback to learn how to raise or lower or adapt itself, which really does much more likely have the propensity to be comprehensively positive and non-zero sum.
I mean, there are some forms of neurofeedback that are, what Roberto Pasquale Marquis, who's the guy that invented source analysis, Loretta, he calls hotspotology. There are some forms of that where you go, and I call it sort of neophrenology. Oh, this pattern means this, therefore let me turn it down. It's too high, turn it down. It's too low, turn it up. A mentor of mine in QEG, a gentleman named Jack Johnstone, was brilliant. He died last year, would say, you don't just turn things up and just don't turn things down. And he's also in sort of in the same role I am, EEG, neuroscience, psychology. And he got me thinking a lot more about how this all fits together and much less about, is there a data marker that's off?
Yeah.
Because that's so easy to misinterpret, to overinterpret. I mean, so yes, we're looking at regulatory capacity, and the forms of neurofeedback that I enjoy, that I approve of, that I like to use, are forms that work on global mechanisms initially, at least.
Yeah.
SMR re-regulates the whole system in attention, sleep, a few other things, seizure, obviously. Alpha training, or alpha theta, which is a special type of training, and involves entering a hypnagogic sort of state, essentially, is also extremely useful for certain things, including re-regulating over-arousal, including causing an immune surge in T cells. So if your T cells are low, there's some evidence you can take them and hack them up continuously with alpha training, actually. Alpha theta is a near cousin of alpha training. The literature, the published paper by Dr. Schumer shows alpha training bringing up T cells. I've seen the effect in people doing alpha theta, so I know it's a similar mechanism.
So I have a question here. When we think about neurofeedback as exercise for the brain and central nervous system, and we kind of play with that analogy a bit, someone can do a pretty tremendous amount of curls, increase biceps, and not really affect lower body at all, right?
Yeah.
And so in a similar, we wouldn't necessarily say doing curls is increasing the adaptive capacity of their musculoskeletal system.
Right.
We would say it's increasing a fairly narrow capacity.
Yeah, I have two things to say about that. One is that the neurons and the microcolumns are not biceps, and they're interconnected much more profoundly. And they're producing electricity, which spreads. And so half the signal you're measuring at any spot under the electrode is from everywhere.
Mm-hmm.
And half the signal is from right under the electrode. So there's some spatial sensitivity, but not profound spatial sensitivity for training. So that's one thing. You're getting some global effects when you do band-based training, with multi-electrodes. You aren't unmixing the signals and doing real-time source analysis, which you can also do. And it has some benefits. When you understand what you're going after, it's huge doing source analysis training. But in general, you're measuring a signal at a scalp electrode. It's a dirty signal, if you will, in terms of spatial resolution. Half of it's from everywhere. So you're getting some global effects when you do regulatory frequencies.
Mm-hmm.
Two, there's a pretty dramatic and measurable plasticity boost throughout the brain that seems to happen when you do a single session of neurofeedback.
Mm-hmm.
And therefore, and continuing neuro sessions. So you're getting a BDNF bath. When you provide this stimulus, the brain's like, whoa, interesting information. Let me try to make sense of that. And it appears like BDNF flood is one of the things you get. So plasticity just goes up. You can evoke motor potentials with TMS more easily after a neurofeedback session than before. And that's a function of the amount of BDNF. So it's a proxy measure experiment that's been done with one single session of neurofeedback, like doubling dropping the threshold of activation of the tissue, which means more plasticity. So it's more interconnected than biceps, and it's also a more global effect. It's almost like if you worked your bicep out and all the bradykinins and other inflammatory molecules got released, caused your other muscles to go, oh, let's all tone up. Then it would be a better analogy for neurofeedback. I do use a bicep analogy when people ask if it's permanent. I'm like, yeah, sure, but you're not stuck in that position either. You aren't turned into somebody with strong biceps. You're turned into somebody that, when there's heavy stuff to pick up off the floor, discovers they have strength, but isn't necessarily flexed all the time.
So maybe rather than biceps versus lower body, we'll look at sprinting versus distance running, which are utilizing the same things in different ways. Yep. And so the reason I'm asking has to do with, what you would call general capacity to adapt to any useful state.
Yeah.
Versus the ability to get into specific states well. So if someone does alpha training and they go into a specific state, and that might be super useful for immune boosting or maybe anything mediated through alpha. Obviously, we know some people who have excessively high alpha and can't get into beta. Is doing alpha training going to necessarily increase someone's capacity to go into beta or theta or any state versus the just capacity to go into that state?
It depends on how the brain works. And we think the brain works in ways where certain frequencies, if they're stuck on, inhibit the change. And so doing any training that breaks those stuck patterns up does improve regulatory capacity. There was a study not too long ago that showed the absolute change, training a band in a certain direction may actually not happen for a lot of people. That's why the QEEG studies in neurofeedback are a little weak, is because the absolute change across a group of people before and after a handful of sessions isn't dramatic or even all that significant. It happens for a few of them. But if you measure sort of complexity in the data. You can look at functional change happening within session. What you discover is the range, the ability of people to change states while doing the session is increasing. So the exact thing you're asking has been demonstrated mathematically, that there's increased functional range in the EEG, even if the absolute band power isn't changing before and after a session always.
Yeah.
In all people.
So, I mean, this is an interesting question. If we ask, like, what is the equivalent of CrossFit as opposed to sprinting or distance running for methods of neurofeedback?
Yeah.
What if our goal is to increase adaptive capacity for any state based on whatever relevant stimuli? How would you think of that?
It's clearly the way that I work, right? I mean, that's the short answer. No, I mean, SMR, alpha, theta, alpha, beta, doing broad bandpass training, it does fit that category because, in alpha theta training, you improve the ability to hit that liminal state between consciousness and unconsciousness, hypnagogia to some extent. But it produces other things as well, like insight, like re-regulation of over-arousal. It's hitting a bunch of things. It's actually where the relaxation response, I think, must come from. Hypnagogia, sort of in between states. It's a transition state. And we hold you in transition states, you get better at transitioning. Mm-hmm. So you're unable, and this is why alpha theta is used for creativity. Creativity, I would argue, big C creativity, is one of these things that takes holding vast amounts of flexible possibilities in your mind, which is regulatory capacity of ideas, at least, creativity. Alpha theta, because of training the ability to do hypnagogic liminal shift, produces increased access to that generative wellspring. So I'd argue that style of neurofeedback, SMR, making the brain more metastable against the seizure threshold, improving transition states, awake to asleep, asleep to awake, improving a few other of those things and used in those mechanisms. I think you can pick 3 or 4 different styles of neurofeedback and do almost anything with any of them. Yeah. But if you do SMR, alpha theta, beta, alpha training, hit the MIG bands and suppress thetas usually. This what used to be called the Othmer method before they invented the infraslow method below 1 hertz. But it's the old Othmer method, is this band training where you say, no, theta is inhibitory, make a lot of theta, you don't inhibit, let's tamp that down. And damaged tissue might be theta or delta with your eyes open, so you tend to tamp it down. Alpha, if it's present everywhere, might make everything stuck. You need to get rid of that. Alpha's inattention, like you alluded to earlier. If you're stuck in alpha, you're kind of like, huh? What? Your timing slow, you process information, you bind information slowly. Your word finding may be off when your alpha slows down with aging. That's one of the causes of normal cortical aging that includes word finding problems. You hit 57, 60, 62, 65, and you can't find the word. It gets bad. It's usually the speed of processing. So your alpha speed indexes that. So this is the QEEG tool, is getting a big but vague picture of what's going on and then going, oh, okay, well, here's your problem right here. Kind of like your mechanic will. You have to trust the neurofeedback person, the QEEG person, like you do your mechanic. They can sell you anything in terms of looking at your complex systems. But it's also not, pure supposition. It's not pure clinical lore. And so we start with the evidence, generate hypotheses, validate hypotheses subjectively from experience, which is weak, at least in clinical practice, and then refine those hypotheses as we get effects from training. And so we steer people better and better towards effects. I think that's better than holding on to a model of how this works that is ironclad, because they're all imperfect. And when you describe the core beliefs of all the schools of thought of neurofeedback, you find they're in conflict. And they can't all be true. And yet most schools of neurofeedback get relatively good results.
So let's talk about why you say most schools of neurofeedback get relatively good results, and yet most neurologists aren't going to say neurofeedback is a particularly meaningful thing, and Wikipedia has a mostly negative slant on it. Can you, obviously, when you talk about how complex it is, how many metrics might be affected or not affected, but yes, speak about that a little bit.
Yeah, I mean, there's, the question that unfortunately this is asking is, why isn't there more gold standard, double-blind, placebo-controlled, high-end clinical data, clinical research studies published? Because that is the decision criteria for the neurologist, for the psychiatrist, is, well, it's not in PubMed at a high level, therefore it doesn't exist. It's a truism, but I think a valid one, that research validation of clinical technique lags by a significant amount of time. It's also true that there are thousands of papers on neurofeedback. Now, there's not 1,000 good papers. There's like 1 or 2 or 3, or decent papers. And that's the real question: is why are there not the same kind of data backstopping? Why is the game not played at that level by the neurofeedback interventionists the same way it is played by the biochemical interventionists? Because it seems like there's a game to be played. You prove this, you get CPT codes for your insurance billing, you prove validity, efficacy, specificity, and you are off to the races because insurance system is the way to go. And so there's a few assumptions in there that we don't have to challenge to point out that that's how it's been. And neurofeedback has not met that particular criteria, and there's some really good reasons for that if you understand neurofeedback a little bit better. One of those reasons, the most valid, the most real, is probably that it's extremely difficult to do double-blind EEG analysis. In real time, you need a signal that needs to stay clean when the person moves, when the software does weird things, and as a technician, you're watching stuff. You could single blind it. You could hide the signal screen from a client and just have a game screen. That would work. Not very good science. Double blind. So up until about 2012 or 2010, you couldn't do double blind research. And there was lots of ways that people worked around it, but it was always some other physiological signal contaminating the person's EEG that was still them. You're still doing something that wasn't, double blind. And then Howard Lightstone, who's the chief engineer lead behind the primary software in the field called EAGER, E-E-G-E-R. It used to be called Neurocybernetics, but it's now EAGER. Howard recognized this problem. There was lots of clinical use, 5,000-10,000 people using it, but nobody actually doing good research because of this blinding problem. So I helped Howard a little bit in terms of fleshing out ideas, but he ended up building this beautiful, it's called the Study Manager. And what it does in real time is it grabs several segments of pre-recorded EEG off the disk. And so you do those yourself and you make them clean. And it takes the live data off the person's head and looks at the power envelope. It takes the segments and shuffles them, stitches them together, scales them to the person's EEG, blends them, and then generates training metrics, training data, feedback off the stored segments only, and generates screen display off the blended EEG. So if the person coughs or moves or unplugs a wire, you get what you expect, and it looks like it's real EEG. But the actual amplitude spacing and band things bear no mathematical relationship pretty much to the person's real EEG. None, actually, because the training parameters are not coming from the blended signal. They're coming from static segments that are stitched together and scaled.
Mm-hmm. That was a tricky thing to figure out how to put together.
Yeah, so Howard did this, and now there's 5 multi-center studies going on in using EAGER, and it's sort of becoming a bit more of a research tool. That being said, in 2012, because of the preponderance of research in things like ADHD, in 2012, the American Academy of Pediatricians raised neurofeedback up to level 1 best support. So table of what's an intervention for pediatric problems, and this is the table for ADHD. And the things in level 1 before that were psychostimulants. The things in level 1 now, psychostimulants, neurofeedback.
Mm-hmm.
Now, this research publication, American Academy of Pediatricians, which is a review board of doctors, essentially, pediatricians, is not an insurance company. It's not the insurance machine. And so that wasn't enough to get it covered very well. It's very poorly covered by insurance. 5% of people might get something back, rarely. Diagnostic EEG is sometimes a little bit more, but QEEG is not exactly that. So, usually don't get coverage from the insurance end of the pool. There have been 5 or 10 or 15 really good studies since 2012 across different problems and different, complaints, things that cost money, things like pain, things like ADHD, but nothing profound yet. And this gets to the other reason why the research is lagging, because to really get coverage in this current, way the game is played, you need FDA clinical trials, phased clinical trials. And here's where it breaks down, because the money to produce the clinical trials and the way the game is played now is in the $1 to $5 million range for a very small study. And that, being neurofeedback, this is more expensive than a drug study because you can't just give people their own drugs to take and do the study well. You have to actually do it. So you're talking about 20 sessions, 30 sessions, 40 sessions, 50 sessions, very expensive way to do it. And, oh no, neurofeedback is a heavily individualized process when it's done the best. So now you need 1,000, 2,000, 5,000, 10,000 and study for participants. And now we're talking about a $5 to more like $20 million study. So while there are some academics doing studies of the 40 people, 50 people, there's no one doing big phase clinical trials because where's the money coming from? The equation breaks down. Pharma pays for their drugs to go through this process. They invest, I don't know, 5, 10 million in research and 5 or 10 million in studies. And they have 10 of those products that they're developing and 3 of them become drugs that are sold and make $50 million each. The math mostly works out. Great. But there's no money coming in the tens of millions to neurofeedback research. And the people doing the neurofeedback research who are getting the best results are mom and pop clinicians, usually psychologists, sometimes social workers or family therapists or nurses or neuroscientists. And some are MDs and some are psychiatrists, but they're, probably a fraction of a percent of people doing this work. And so it's in this gray area that is not medicine because it's not done only by MDs. And it's not psychology because you don't have to have a clinical psychology license in almost every state to do this. Mm-hmm. And it's not, sleep EEG, polysomnography, and it's not epileptology, but it's still EEG. And it's not really personal training because you kind of have to know neuroscience and a pretty heavy duty tech, skill set to do this well. But it's closer to personal training and how it's carried out. I think it can be, the core of it can be personal training with your very attentive, very intuitive, but very well-educated technician helping assess, identify problems, dial in possible solutions, working you through them, evaluating them, and fine-tuning as necessary. So for me, the natural evolution of the field is into personal training, not more and more medical. And a lot of the clinicians, half of the people out there are clinicians or more, they want this to be fully covered by insurance and, at the same time that most of them are dumping insurance and running the other direction. So it's a very scattered field of 5,000 people in the US, let's say, and it's not very cohesive, and most of them are small clinicians, and there's no money in doing research, but they're getting great results.
So we have talked about this in the context of functional medicine, personalized medicine, the same way, where we're not looking at does a drug have some effect beyond placebo across some large number randomized population, but does a personalized medicine protocol, which is going to be different for everyone, have some meaningful effects on some pattern of lots and lots of metrics. And this now is something that requires a scientific process beyond clinical trial.
It moves up to machine learning and big data, and we're in that space suddenly. And this is the biggest data you could imagine because it's EEG. EEG is bigger data than anything. It's bigger than image data. It's bigger than MRIs. It's the most chaotic. It is the most dense data set. The reason my PhD took me a couple of years is because, many years, is because I had 20 or 30, terabytes of data that I had to process through to get my answers. The joke goes that a physicist will spend a year planning an experiment, do it for an hour and have an answer. And an EEG scientist will do an experiment for an hour and analyze the data for a year and a half. Mm-hmm. It's this incredibly a dense space that requires phenomenal reduction, but reduction that actually is to some model that is meaningful. So you can learn things and use the data in some way. You can reduce it and noise, reduce it and break its reality, compared to the individual. That's a problem. So.
Okay, so if there are people who want to learn more beyond what we talked about here, to really have a sense that the epistemology is good, even though it doesn't look like double-blind placebo-controlled trials yet for all the reasons that you mentioned. We've only been able to do double-blind trials for a little bit of time, and it's personalized effects and what metric do you look at, and et cetera. What would be resources to learn more for someone to really have a sense? Because you're saying things like 80% of people with ADHD have positive results and et cetera. Where would people go to learn more?
I mean, there's, of course, stuff on PubMed.gov, and you can search there, and you can find things there. Neurofeedback, EEG and SMR, those two keywords, produce a great deal of information that is sort of backstopping a lot of what I'm describing as the history of the field the past 50 years. And you can find some things there. Actually, quite a few good papers. But you can also go to the ISNR website. That's the International Society for Neurofeedback and Research. They're the sort of trade organization for the neurofeedback world. And they have been maintaining a bibliography of all of the research that's available across complaint, categorized by complaint. So you can look it up for Tourette's or ADHD or autism or seizures or migraines or peak performance or aging or anything else you want to look at. We also on our website, the Peak Brain Institute website, have what we think is a good sampling of some studies. We've highlighted that, talk about it for anxiety or pain or ADHD or things like that. But it's also, I encourage people to think about this, again, as closer to exercise. Yes, the research is there for exercise because it's a little easier to do research. We've been doing it for longer, exercise for longer than neurofeedback, one would, argue, at least technologically assisted neurofeedback. But exercise is the sort of thing that you do, and pretty quickly you go, oh, okay, here's what's happening. This actually works. And there's no placebo effect when you're sleeping better and you're much stronger and you've dropped 20 pounds of adipose and your pants fit different. And, the same thing can be said of neurofeedback, that for most forms of neurofeedback, the effects you get show up initially within the first couple of weeks. And so it's not a phenomenally huge investment to do a month of neurofeedback, 10, 12 sessions or something, and go halfway into it, wait a minute, oh, okay, this is what this process of neurofeedback is doing. Now, you do have to sort of pick your neurofeedback technology a little bit. And this is, I have some bias here. I'll fully admit that. But I do think that using QEEG is sort of a threshold for adequate neurofeedback preparation. Oh, this person records a cue and uses it to understand my brain. Okay, they're at least, not operating off in la la land fully. And it takes time and effort and energy and money. It's very expensive to learn QEEG. The machine's expensive. The databases are tens of thousands of dollars. The knowledge to process and interpret QEEG reporting, metrics, takes years. So that's just so expensive that if you're going to be somebody who settles for woo, who settles for purely magical thinking and maps of the world and models of the world that bear little resemblance to how things actually work, if you settle easily for those things, you generally don't invest heavily in nuanced skill sets of science. And so if you're somebody who's really dug into QEEG and you're doing recordings and interpreting them and you use them to guide your practice, even if you started off believing neurofeedback was magic fairy dust, you've learned it isn't, because you've learned so much about the brain in spite of yourself that you now do evidence-based neurofeedback. So, it's such a high investment that it becomes this sort of weed out factor in some ways, I think. Because if you're like, no, I have a bunch of great protocols, they always work, and I never look at the person's brain. Well, you may think they always work, but I know that your efficacy is lower than it could be, and your side effects are higher than they can be, at the very, very least. The person may get great results. You have a great trainer. But if you're picking somebody randomly, pick somebody who probably uses the best tools. And QEEG, at least as an assessment device, is a big clue towards that. So I would say you can look at PubMed. You can go to isnr.org and look at their bibliography. Go to Peak Brain Institute and look at our some selected articles. But honestly, you can find a practitioner and just do some training. And one thing about training and doing biofeedback or neurofeedback is that this is, again, learning, not some special type of intervention. Like a drug, drugs often work best, chemical interventions often work best when they're profoundly well targeted. Chemotherapy is now becoming targeted to cancer. You do a genetic sample of your cancer and get engineered chemo that only attacks the genetic signature of your cancer. That's incredibly exciting. That's like beautiful types of science. But many earlier drugs for mood and psychiatric stuff are big giant shotguns where they hit stuff and we often get a benefit. That's kind of interesting, but they're not clean in their mechanism, not precise. So you can do some of those things with neurofeedback and just see what happens, because there are often very early and quick effects. So, or you can dig into research and decide for yourself that there's enough there. We typically have people do 3 months of training initially because it takes time. This is the other reason why neurofeedback is not profoundly well adopted. Why don't we have incredible core muscle strength, abs, profoundly great cardiovascular range and tone and capacity, and perfect blood lipids, perfect hormones? Why don't we have those? Because we almost know everything we need to do to get those things in range. oh, wait a minute, it takes dropping all sugar and going and doing exercise at least 3-4 times a week for cumulatively at least 2 hours a week. Wait a minute, it takes some effort. That's why neurofeedback isn't well adopted. Everyone finds out what it can do, and a month in, when they're feeling like all of the limits they thought were permanent are no longer permanent, are lifting, everyone asks me, why doesn't everyone know about this? Why isn't it everywhere? Because this is amazing, and I need to do this. And the answer is simply, why don't we all have great, cardiovascular core strength, great abs, whatever? Because it takes time, and you have to go throughout, 3 times a week is what we do, maybe for 3 months, 4 months to get a permanent change for many things. But it's this process of going and working with a trainer and getting some exercise. You go work with a personal trainer, you or I, for 3 months, 3 times a week, working out strictly and getting some support around how we lived our life, some biohacking support. Oh, you probably shouldn't eat Krispy Kreme donuts more than once a week, some broad strokes like that. Those things will change you profoundly in 3 months, and the abs will show up probably, right? If you're getting the right kind of support. That's what neurofeedback is. It's not analogous to Adderall or Ritalin or modafinil or even, things like paracetam and other nootropics. It's not in the same category.
Right.
It's much closer to you're going to tune your system up and exercise it and change how it works, or are you going to just react to the stressors, the motivators, the demands, the things that are coming in and out of your body?
Which means that it has the capacity for much broader, more comprehensively positive and more enduring positive effects, and takes more input.
Right.
Now, I would imagine you might not have formal data on this, but you might have an intuition or a clinical sense. Why don't we all have good core strength and abs? Some of the behavior changes are not only like that they take energy, but they take actually going against some fairly lifelong addictive, difficult patterns. So what is your experience with if someone is actually doing SMR training first and they're increasing their capacity for impulse control, that then translates to not just the benefits of SMR, but increased capacity to do other things like exercise?
Absolutely, and it does. I mean, somebody comes in with alcoholism, quote unquote, and they need 2 things. They need SMR training and alpha theta training, at the very least. They may need more than that. And the reason they need alpha theta is because they need to re-regulate the brain's inability to produce GABA, or alpha, essentially, which has been suppressed through exogenous drinking for many years. So the brain stops producing it, becomes stuck in this beta heavy state. So re-regulate it with alpha theta, and you do the SMR, not really to work on the alcoholism directly, but maybe to work on the impulsivity, the anxiety, the difficulty sustaining stillness with your emotions, et cetera, all the inhibitory tone stuff. So I would argue that instead of thinking about it like a specific problem, you think about it like, again, resources, where SMR is inhibitory tone. And if you have good inhibitory tone, it means you're not going to be ADHD, but maybe you weren't to start with. Maybe you're only impulsive around that extra yummy learning thing that happened when you got alcohol reinforced for a bunch of times. Maybe you have that gene that makes you find alcohol even extra rewarding, and so you learn faster. That's a process that happened, and SMR will give you just a touch more inhibitory tone and make you more successful controlling behavior. If you do if OCD or PTSD-like problems and your anterior cingulate or posterior cingulate is stuck in a beta mode and spinning your mental wheels and burning cycles and being really inefficient and monitoring the environment constantly, well, you can slow that down by tamping those betas down and replacing them with a little bit more alpha. So none of those models about how the brain works are accurate. Math is not the territory here in the slightest, but they're useful. Mm-hmm. Knowing that there's an overarousal syndrome that involves GABA and probably alpha, and I can work on it with alpha theta neurofeedback successfully most of the time. Peniston, who developed alpha theta, the Peniston protocols, discovered that in a population of alcoholics, you could reverse recidivism. Move it from like 3 quarters or 2/3 down to 1/4 or 1/3 in terms of relapse rates. They just reverse. And Doug Quirk did the same thing with alpha theta in prison populations in Canada. 7,000 prisoners reverse recidivism, went from 75% recidivism to 25% after alpha theta neurofeedback. And then David Kaiser and other people, probably Jay Gunkelman was involved, did SMR training interspersed with alpha theta. And the Peniston protocols, the first alpha theta protocols, had visualization audio tracks along with the actual biofeedback. And a couple of guys came later and just did the SMR interspersed with alpha theta and got the same kind of behavioral re-regulation.
Mm-hmm.
So it's really much a question of finding models that are roughly accurate more than necessarily valid.
So this is interesting. If people read Jill McGonigal's book on the willpower instinct and just the sheer amount of data of impulse control related to quality of life metrics everywhere, right? Starting with the 2 marshmallow experiment. There's a question I think a lot of people have regarding all the things that they want to invest their time in. Which ones should they do first? It increases the capacity to do others because they can't really increase their learning in specific areas and make their finances better and make their health better and their relationships and optimally at the same time.
Mm-hmm.
So a lot of people say, well, let me learn how to speed read so then I can read other books better, except speed reading mostly sucks. So, I mean, this is actually kind of an interesting proposal of if someone invested in some deep neurofeedback work early on, increased capacity to actually do anything else and stabilize those things is a pretty interesting argument for putting it low on the stack.
Yeah, and this is why about a third of our clients at Peak are peak performance clients, no pun intended.
Mm-hmm.
That's one reason why we picked the name, because yes, I have ADHD people and people with autism and cerebral palsy and brain injuries and migraines and anxiety and PTSD and all kinds of diagnoses, quote unquote. But about a third of my clients are people who are incredibly high performers who are trying to remain or gain from there, or elders who've decided they don't want to experience slowdown or maybe experiencing non-pathological changes and they want to shore them up. And I would say it's about half and half in the young, high-powered biohacker CEO, Ben Greenfield, whatever, kind of like, let me squeeze out the extra 5 or 10 or 15%. And those guys train forever and train, for a few months intensely and then drop intensity and just keep going long term. Some of them on their own, some of them, at our centers. And some of the elders will just shore up the slight drop in processing speed and get the word finding back and get the sleep regulated, back on track, slow down the aging trajectory probably, and are, good to go. Many of my clients move from a fix to a fitness mentality over time. Yeah. Anyways, I have ADHD and nothing works in my life because I'm profoundly ADHD. I'm that kid in the family. I'm the one who can't do anything right, who can't get out of the house, who's fallen out of school, who's made all the bad decisions apparently. That kid comes in, that adult kid as an ADHD person with profound ADHD. There's been a couple of those. We fixed the ADHD. And all of a sudden, they're profoundly sort of capacitive in their ability to take control of their life. And they end up becoming the person who's like the organizer of the family dinner, who's like keeping everyone calm and communicating well during the chaotic environments and things like that. So is this treatment? Maybe if I was a psychologist, but otherwise it's something different.
So I want to go through a bunch of questions fairly quickly that I think might be on people's minds.
Okay.
So you've mentioned it, but let's categorize the categories of things for which this is interesting, because you've already mentioned cognitive things.
Yeah.
You've mentioned kind of psycho-emotional things. You've mentioned physiologic things like immune, on the negative side, and obviously
pain.
Performance on the positive side.
Yeah.
And you haven't mentioned it, but many people have kind of spiritual states, right? Numinous states so meditation training.
Yeah.
And we have both decreasing dysfunction and then increasing function or capacity.
Yeah.
And just kind of speak to what each of those categories, some of the main things that we've found are.
So I often look at what my practice is and who comes in. It's a selection bias, but I end up with a third roughly in each category. And I roughly categorize it as psychology, neurology, and peak performance. And neurology includes things like autism and other developmental disorders and seizures often, and migraines and brain injuries, all of that, And then psychology is the biggest bucket, including, ADHD is probably neurology as much as anything else. But then psychology or sleep things often, and anxiety. I'm not saying they're in the mind. I still think they're in the brain, but they're a function of the brain learning to be in that state because of internal, external demands that made it learn that way. Depression fits in that category. It's learning. All this is learning. Addiction. This is all learning. And then in the peak performance are things like processing speed and anti-aging stuff and vigilance and creativity for alpha theta. Pain fits in that category somewhere. But I'm not sure, it's in the neurology or the psychology space. It might be in both. It might be in peak performance. A hardcore athlete who's only sore because they work out like a Ben Greenfield every day for 4 hours or whatever he's doing these days, or a Tim Ferriss who's like throwing himself off of buildings now and climbing and, doing crazy stuff all the time. These guys are probably in pain a lot because they're hard charging individuals. And if the pain's in your body, it's probably also in your mind a little bit. And so we can do psychology stuff for pain, which is actually in the same rough area, according to Neil Eisenberger and others. On the right front, there's some emotional pain and physical pain centers. And if you train them down and you have chronic pain syndromes, they drop. And if you train them down in a little different way and you have chronic emotional pain syndromes from attachment problems or deep heartbreak or PTSD or whatever else is going on, you can tamp those down. So it's not really a question of what we can work on. It's almost more of a question of what we can't work on.
Sure.
The list becomes small. Something in point of view of a system, you can work on it very, very well with neurofeedback. Attention, sleep, stress, mood, attention switching, which covers things like OCD and Tourette's. Those are both sort of switching problems, if you will. Seizure, migraine, PTSD, reactive attachment disorder. You can work on things even like bipolar disorder and schizophrenia. I generally don't, A, because I'm not a psychologist or a psychiatrist, B, because, especially for schizophrenia, you're talking about something where there's a sort of active disease process almost fighting against you. And if you stop coming, it stops working. And so it's harder to get a permanent change, much, much harder in something with an active disease process. I also don't generally work on, severe Alzheimer's, dementia kind of things, because once you've gotten that far, you've lost so much of the scaffolding of the system, the tissue, that you probably reduce the ability to learn and remember. I mean, when people ask about Alzheimer's, I point them towards other things like Dale Brazennan's MEND program, which apparently can reverse Alzheimer's by controlling metabolic factors. But once you're very, very, very profoundly impaired like that, neurofeedback might not be the best solution. That being said, you're profoundly brain injured, having lots and lots of seizures, it's exactly the right solution. So regulatory systems. So if the machinery for them shot, like in Alzheimer's, you can't do much. But otherwise, you can do almost anything.
Yeah, I mean, it sounds like the neurofeedback is to kind of the top-down regulatory systems, like genomics work is to the bottom-up systems. And I mean, there's very little in the psyche or the physiology that is not affected, if not profoundly regulated by the top-down system. So someone could come in to see you for anxiety, but they also happen to have sleep issues and they also happen to have some immune issues, and you just factor everything going on as part of how do we help their top-down systems increase regulatory capacity. I'm curious.
Yeah, I do factor some of them in. Other ones I don't factor in. I just take approaches that are broad.
So I'm interested in the interface of kind of comprehensive neurofeedback trainings like you're doing that might include alpha theta training, SMR, et cetera, with other forms of comprehensive training like functional medicine, like the Bredesen protocol if someone's dealing with some kind of neurodegen, like good methods of psychotherapy. So at the intersection of either psychotherapy and neurofeedback or physiologic work and neurofeedback, depending upon people's need. And how much has that been actively explored?
I mean, it's explored only in that often health and optimization wellness professionals will do more than one thing and encourage more than one thing. I mean, we do a lot of mindfulness and meditation in all the centers. I run neurofeedback. We always offer meditation or mindfulness because we find when people do both work better. My Peak Brain Culver City office shares a wall with a great Ashtanga yoga studio. And so some of our clients will do Ashtanga yoga 6 days a week in the morning, and then they'll come in and do neurofeedback right after. Very aggressive, if you will, physical training. And I've also had clients that do physical therapy sort of hand in glove with neurofeedback. And for the exercise clients, for the clients that do physical therapy, when you add the neurofeedback, the physical stuff starts to change faster. So physical therapy that wasn't really working that well suddenly unfolds. And that's probably plasticity. I've had clients with traumatic brain injuries that are getting better, but still have, with the TBIs, you often have sort of a 2-step forward, 1-step back, or 3-step forward, 1-step back kind of effect where you're taking longer to make change, you're working the brain out harder to really get it to stick in traumatic brain injuries. It's not quite as simple as like ADHD or anxiety. And so as we're training these guys, sometimes I'll say, okay, why don't you, come next door and start working out like I'm, like hardcore for a month or two. And a week or two into doing yoga and then coming and doing neurofeedback, the gains that we're getting earlier on are back and moving faster. And it's at least partially sort of doing all these down dogs with your head down and driving blood into the brain. It must be. But it also is true when people work out at their gym and then come in and train, or vice versa, do neurofeedback almost as a pre-workout, get all pumped up, get, focused, get plasticity factors going, and then hit the gym hard, you find things change. But these are all subjective experiences that are, pretty ungraded, unmeasured. But I hear it again and again and again. So I encourage people to add whatever other interventions that are behavioral to their life, be it speech and language training for a kid, or tutoring, or language learning, or yoga, meditation, whatever it is, whatever behavioral, modifiable behavioral hack you can do to increase skill learning, change, moving in the right direction with the brain, plus neurofeedback, is a good idea, because everything seems to work better. I mean, this is not necessarily, it's at least partially because of plasticity neurofeedback, plasticity enhancers, but it's also sort of the science of human transformation. When you add more intervention strategies, when you hit a certain magical threshold, it's like 4, human hacking intervention type things, the chances of having a discontinuous change, the linear, becomes almost certain. So you add 1 or 2 things, you get change. At 3, you get a lot of change. You add 4, you're going to get some profound, amazing thing happening. And so I'm a big fan of people adding lots of interventions when they're trying to make change. But I actually tell people usually not to take nootropics when they're doing their feedback for the first couple of months, because I want at least not them to start to take nootropics. If they're on them, fine. If they're have it dialed in, great. But often people want to start and they want to get everything done.
Sure.
And I'm like, great. Well, happy to suggest some nootropic strategies for you and dig into those things, and even like your sleep hacking and diet and exercise and everything else is all important things. But why do you not change anything else right now? And you can just do some, neurofeedback for a month, and let's see where we can shift your baselines. And then we'll take it up a notch with nootropics, with whatever else. And we usually dial in lifestyle factors. So we're not purely hacking the brain. We're also doing a little bit of life hacking for people, usually supporting that, vision for people.
So a few kind of last questions for people to have a sense of how to move forward. Home units. Obviously, a lot of people are using Muse right now to start getting some sense. And most of these units are dry leads and not that many leads. And
the wrong locations for training, most of them.
Are there any home units that are good? Are there any that are worth using? Are they problematic? What is your sense on that? Would someone be better to just do HRV
My sense
training?
is, you're better to do HRV training is probably true. If you want to do some biofeedback at home. The EEG, neurofeedback systems that are home consumer-based, have many problems like you've described, and those are all big problems and true problems. Wrong location, bad signal quality, too few connections, yada, yada, yada. The bigger problem is that neurofeedback is not one thing. And that you might not want to do one thing for one person. You might not want to, stay with what you're doing once you get a certain effect. And so learning how to do a neurofeedback protocol is not rocket science. Learning how to do neurofeedback. So even if the tool you bought for $100 off the shelf did what it said it did, and then none of them do, you still wouldn't just want to do that thing.
Now, if someone is coming and they're training with you, and then they want to be able to do some ongoing training on their own in between, are there some home units that people can use that are meaningful once they've already got some training and maybe with check-ins?
And we do that, and there are, and many practitioners do that. There's sort of devices that are at the intersection, price and complexity-wise, of clinical and sort of prosumer level uses. But they're not consumer pricing. I mean, we put together a system at a pretty low cost, quote unquote, and it's pushing $4,000.
Right.
If it includes HEG, hemoencephalography, which is blood flow, infrared blood flow training for migraines, it's about a $4,500 system. And that's just the hardware.
Right.
We got to spend a few days with you, working with you to do assessments and teach you to set up systems and set up your protocols. And then we send you home, and for 3 months, we do weekly check-ins, chart review, support, like you're describing. And the biohacker can get a lot of mileage that way. And the motivated mom or dad who's got an ADHD or autistic kid can get a lot of mileage that way. The profoundly anxious or ADHD person trying to train themselves cannot.
Mhm.
If your thing is a thing that gets in the way so much that you can't be productive and you can't do things without a certain amount of, just doing them and brazening through and figuring out some computers and some technology, then it's not ideal. But yeah, we do a lot of that for clients either start in our office and then want to become home trainers, or clients that are only able to come to one of our offices for a few days. And in 3 days, we can do a QEEG and do 2 practice neurofeedback sessions with you a day and teach you how to log sessions and do that kind of thing. And we do a lot of that. And of course, we also open more offices all the time. Yeah. So we're trying to open up in lots of cities as well. But our goals are a little different than the average neurofeedback clinician who's going to work specifically on, more of a therapeutic, psychological, medical perspective. We're trying to make this, sort of like the brain gym or the brain spa, and
Right.
Teaching someone to use the sophisticated equipment and get a good training program going fits that methodology, even if they're not working out in our center. So we're happy to, extend the knowledge management piece of it to clients that are self-directed, computer savvy, and want to hack away at their own brains.
So one of the goals of Neurohacker Collective is being able to really identify, kind of like the first part of neurofeedback, being able to separate signal from noise, amplify the signal, synthesize the signal, and then, in the whole space of what's actually effective for people. And so we want to be able to help identify and curate resources that people can use to actually reliably help themselves. I really love the approach you're taking of being able to get well-trained people who aren't trying to do one thing, but are trying to actually help increase adaptive capacity of the top-down systems across a lot of goals, done well, and increasing, having centers in more places. I think this is a hugely important thing. Is there anything that can help you with this mission?
Sorry, I just lost you there.
Okay.
Now I'm back.
Where'd you lose me? We'll go ahead and edit that out.
You really like how I'm doing it, getting well-trained people.
Yeah, so coming back in, I really like the approach of not just doing one therapeutic method, but really helping practitioners understand more complexly how to be model agnostic, be well-trained in the models, have good equipment, and actually be able to do good comprehensive neurofeedback with people, and also be able to interface other things, like whether it's yoga or other methods for traumatic brain injury. And so I think training on at home is a difficult enough thing, as you mentioned, if someone's already got very difficult things going on. But it's just, there's a reason that yoga studios exist, is it's just hard for people to do for any reason, right? For many people to do for any reason. So I'm delighted that you're getting centers in more places, getting more people trained, getting better software systems so that people can do higher quality work at the level of their training. Is there anything that you could use to help advance what you're doing? Like if there's a city that you're not in yet and people are interested in helping it get to that place, or...
Yeah. That's a big question. I mean, we have a pretty aggressive goal at Peak Brain for growth. And, right now we're in 4 cities. We're in San Diego, downtown Los Angeles, Culver City, Los Angeles, and St. Louis. And then we have some concierge technicians who live in certain cities like Portland, Oregon, like the Bay Area. Our goals are to open up 50 centers internationally. And in 2018, the goal is to open another 5 to 10 throughout the US. And in 2019, to open another 20 to 40 throughout the world. And we're trying to become a big company, and we're still a small startup. We're less than 2 years old. We've been running for 21 or 2 months. I got my books finally sorted out and saw that we made $8,000 so far for the company. But I've also put a couple $100,000 into growth. I mean, we're not flat revenue in that way. We still made some money, but we're putting all of our resources into growth. And at some point, we're going to have to break out of that. Me as a mad scientist trying to take over the world and save the world from a neurofeedback perspective into a large national company. I'm not quite sure how to get there. We're trying to build data tools first.
Yeah.
And that's probably the thing that I need the most help with is, probably need to find myself a good CTO to manage that piece of it. But maybe just a good UX, UI, Django full stack developer right now would be great. If there's one listening who wants to get involved with some good biohacking.
So whether it was someone that could help with the data science, the software, the UX, the UI, real estate, or fundraising, they can contact you.
They can contact me, and we have some pretty, big ideas, and I think we're well positioned. I mean, I think there's really two companies in the neurofeedback space that are best positioned for big national presence. And one of them is Peak Brain, because we've got 4 centers, and because I happen to be kind of old in the field and I've done it for a while and I know how it's done well and I know what mistakes not to make. And the other one is actually Betsy DeVos's NeuroCore, because she's the Secretary of Education, and her VC company has a pretty heavy investment in NeuroCore, which is a network of neurofeedback centers in Michigan and Florida. And they've announced they're going to double their footprint. Mm-hmm. So from my perspective, if there's sort of governmental level, high level individuals who are pushing this and they're trying to become big players in the space, and I'm kind of trying to take the little solo clinician and make it the Equinox or Gold's Gym of the brain, those are different goals. An education-oriented center, which is what her things are, or Peak Brain, which is more peak fitness. I think at some point we're going to have enough pressure, societal pressure, that will be these massive organizations. People will demand this stuff when they realize what it can do. But there was a time before there was a Gold's Gym on every corner. And I think that's where we are for the brain. No one quite realizes they want to look like or feel like or be like they can be. And access to this technology is what I'm trying to solve. I'm not sure yet how to solve the piece about awareness, full brand, full marketing, if you will, not from a point of view, more Guy Kawasaki evangelism than true marketing in this case. But I'm always happy to talk about neurofeedback. I never care. I mean, I care a little bit. My CLO would kill me if I said this, but I never really care if someone trains with me. For me, it's an evangelism thing where, oh my God, this stuff exists. You don't have to be satisfied with your brain. Shift happens. Take control. It's going to happen anyways. The brain's whole damn job is to shift. Why don't you decide, what direction it's going to move in? And this can do that. Find somebody. Let me help you find somebody. Come see us. So I'm pretty passionate about this idea that you can do it, and you can do it with a psychologist or a personal trainer or a psychiatrist or an autistic specialist, ABA therapist who does neurofeedback or something. Doesn't really matter. What you're losing out if you're sitting on your butt and not doing neurofeedback, watching TV or something. You might as well sit on your butt and do neurofeedback.
So make sure that they do QEEG first. And other than that, are there any other guidelines of what to look for, what not to look for if someone wants to train with someone in a city or not?
Yeah, there's a couple of keywords that are usually red flags. And those include words like quantum and detox. Generally in the health space, when those words are invoked, they're invoked as obfuscatory marketing language. Oh, and nonlinear. Did I say that already? Nonlinear is a big one. It's an important one. So if you're somebody, if the reason they tell you it works is language you don't understand, and when you ask them what the words mean they've used, they can't explain them, you're probably not working with somebody you should keep working with. And if they don't say I don't know as often as they say I do know, that's also a problem in this space. You don't want somebody who has all the answers. You want somebody who has all the tools and is going to help de-obfuscate or mystify the neuroscience for you. You don't want a magic practitioner of wizardry. You want a very skilled mechanic or personal trainer who can break it down for you and give you a sense of what your options are, not take control, and not like in the 50s we used to do with medicine, which is, oh, okay, whatever you say, I'm just going to do that. This is your brain. It's never the brain of the person who's working on you. And you should be making these decisions. So the more they include you in here's what your data means, here's what we're doing, here's what we're trying, where do you want to go, the better you should feel about the process.
So QEEG and basic critical thinking of if they they are doing a realistic, scientifically informed job.
Yeah, and also cost. I mean, this stuff is often very expensive. The average person charges, like a psychologist, about $150 an hour.
Yeah. And
so, cost should not be the reason you do this, even though it's quite variable. You'll pay between, $5,000 and $10,000 for a full course in neurofeedback. Mm-hmm. But, if that's $10,000 spent towards woo-woo hardware that doesn't do anything and has broken interface and a technician who's just using one-size-fits-all stuff, it's a wasted $10,000. But if it's $5,000 or $10,000 that eliminates your ADHD, fixes your sleep problem, eliminates your seizures, improves your productive output, deepens your sleep, makes you Mr. Creative. It'd be cheap at 50 grand or 100 grand, or it lifts your kid's ADHD, or it lifts your kid's autism symptoms by 10% or 20%. That's priceless to people with problems. So it's not a very price sensitive field. And it's also a niche with about 5,000 practitioners in the US at most, which keeps the pricing relatively high. So people have to navigate these things, unfortunately, when deciding who to work with and how to work. Hopefully they can get a sense that there's lots of different technologies out there and there's a little bit of a difference between them. So starting with QEEG, at the very least, partitions that space towards reasonable practice.
So we'll see what kind of questions come up from this podcast. There are a bunch of follow-up questions regarding fMRI neurofeedback and HEG and the PONS unit that's happening at University of Wisconsin and a intersection with transcranial stim and all kinds of fun things. But this was a fantastic introduction to the space and the field, and I really appreciate you coming on. And I really appreciate both the work that you're doing in the space and that your come from is you don't really care who they're working with. You care they're getting good work. This is exactly our come from too. And I want to change the world. All of the Adderall, all of the Ritalin, all of the methamphetamine, all of the poorly working psychoactive drugs we use for 90% of things, sleep drugs, anxiety drugs. My goal is to eliminate those for everyone. And I can't do neurofeedback on everyone. And even if I open 50 centers, I can't work on everyone. So I'm trying to effect a sea change that I happen to sail on. Well, we share that mission and are coming at it through different directions, but I love the direction you're coming at it through. And if we can be of support ongoingly, we will. And thank you for this today.
My pleasure, Daniel. Thank you.
Thanks, Andrew.
Thank you for listening to Collective Insights. For the full show notes on this episode and for more great interviews, visit us at neurohacker.com/collective insights. If you liked this episode, please subscribe to the podcast and leave us a 5-star review on iTunes.